One of the most important things a robot can do is navigate its environment, and we call this the algorithms that allow us to do that path planning. The idea behind path planning is that we have some robot and an environment, and we have to figure out the chain of actions that takes us from the starting location to the goal. And that creates a path that doesn't intersect any obstacles, what we know as a free path that allows us to navigate to the goal. There's a couple of different approaches to path planning. One is called exploration, which is undirected. And the idea here is that there's no specific goal. We're just wandering around the environment to kind of see what we can see. In true path planning, it is goal-oriented. So we're shooting for a very specific location where we want the robot to end up. In exploration, we are doing reactive sort of navigation, where if there's an object in front of us, we try to go around it. We don't really plan very far ahead. In path planning, it's predictive. Usually we have a kind of map, or at least a layout of specific large-scale obstacles that we have to orient ourselves around. In exploration, it's entirely uninformed, so we don't know what the world looks like right now, and we have to sort of just do the best we can with limited information. With path planning, often we have what's called a priori knowledge, or prior knowledge of the environment that allows us to figure out where things are and do our large-scale path planning. What that really looks like is, in exploration, we kind of do things that are going to hopefully guarantee us achieving our goals, but not necessarily the most efficiently. So in the example that we have here, we've got a maze that's following the right-hand rule. The right-hand rule is entirely based on local information. So when the wall on your right goes away, you turn right. When you hit something in front, you turn left. And that's the only two rules. It doesn't matter. We don't have any information about the rest of the maze or anything like that. And you can see that it doesn't take the most efficient path. However, if we were doing true path planning and we knew the whole maze, then we could take the most efficient path from start to finish and not have those little extra detours. The whole idea behind path planning is to figure out what the state transitions between our situations are. So for example, if we start off with an orientation of our car that looks like this, and we have some goal that we want to reach, how do we figure out how to take intermediate steps to hit that goal one at a time and achieve it, right? And what this requires is some knowledge of our environment and also knowledge of how the robot can move through the world, because in this case we have a robot like the one that we're using in our projects, where the front wheels steer and we would have to take a non-direct path. We can't just like turn in place and then move directly to our goal. We have to use the restrictions of the motion of the robot ourselves. If we're doing true path planning, we have to integrate what we call the robot kinematics, the rules for motion of the machine, of the platform that we're using, into the path planning algorithm, because we're going to get very different paths based on what the robot is actually capable of doing. Usually it's too difficult to plan all of the robot kinematics all the way to the goal. If we have a very long distance goal, if it's something is far away, then that's a lot of tiny, very precise steps that we need to make, and that's usually too complicated. So what we end up having is what's called a local and a global planner. And the global idea behind the global planner is to lay out a rough sketch of the overall path that the robot should take. So it kind of does the large-scale planning to moving between the start and the goal, and it maybe only a little bit considers the robot's kinematics when it's planning this path. And we can use a lot of different kinds of algorithms for global planners. For local planners, we're considering the specifics of how does the robot sort of go from waypoint to waypoint, location to location, along the global plan, and avoid obstacles that are local to it. So this one very much incorporates the kinematics of the robot, of what the robot is able to achieve, and that way we have local planning that takes care of the very fine-grained planning of how much should I turn in this direction in order to achieve my waypoint and avoid obstacles, and the global planner sort of figures out the high-level sort of plan between point A and point B. You can kind of think of it as sort of planning a road trip. right? When you're planning a road trip, you think about the roads you're going to take, but not the specifics of when you're going to turn the wheel, when you're going to use the brakes and stuff like that. Your local planner, as you're driving a set of instructions given to you by Google or something like that, is what's dealing with the local plan of avoiding other cars and stopping at stop signs and stuff like that. And the global plan of what streets to take and how to navigate the city is what gets you from point A to point B.